Today we're going to talk about solving inequalities. There are certain properties that we had for equality. There are similar ideas hold for inequalities. If you have a statement of x less than a, it could be less than or equal as well. Here. If you have x less than a, then by adding a number to both sides of the inequality, you still have the statement as a true statement. So if I add c to left side and add c to the right side of inequality, this is still less than or equal. If I subtract c, it's still less than or equal. But whatever I do on left side of inequality, it's exactly the same. As long as we haven't discussed multiplication yet, but as long as you're adding or subtracting a number, it doesn't affect the inequality. If you're multiplying a positive number, the inequality still holds the same. So if you multiply a constant c times x, it's still going to be less than c times a if x is less than a. But if you multiply a negative sign, number that is below 0, so let's say if you have 2 less than 4, you've accepted that. And then by multiplying something like -1 to both sides of the equality, then now it's not a true statement because left side it's a -2, right side you have -4. -2 is not less than -4. Actually, it is exactly the opposite side. If you multiply a negative number, if c is a negative number and you're multiplying it to both sides of the inequality, then the equality will flip over, and instead of being less than, it becomes greater. If it's greater, then it becomes less than. These equalities are still there. We'll go through this in the examples, but it's not super complicated. So if you're multiplying or dividing by a negative number, you flip the sign. Otherwise, you keep the sign in the same direction. We're going to use this idea to solve linear inequalities. And later on, at some point, we will discuss how to solve higher degree. If you have quadratic inequality, then what do you do? Okay, let's look at these simple examples. 2x minus 1 less than 5. By the property that I can add number to both sides of inequality, I can add 1 to both sides. And what do I get is 2x is less than 6. This is still a true statement. I can divide both sides by 2. Since it's a positive number, I don't need to change the sign of the direction of the inequality. So x less than 3. This is my solution set. There is a format for writing the solution set for inequalities. It's very common. So solution set. You write it this way. You say all those x's, this is the notation. X's, so if you see it, this is the way. All those x's such that, this straight line means such that here, x is less than 3. This is how you read this statement. So all the x's that are less than 3. This is my solution set. They might ask you to draw these set. So how does it look like? This is the number line from negative infinity to positive infinity, if you want to think about it. Here is 0, 1, 2, 3, and so on. -1, -2. Okay. Where is 3? Here is 3. 3 is here. X less than 3 means this is 3. X less than 3 means all those numbers that are smaller. All these. If they ask you to draw the solution, this is your solution set. There is an important thing that you should notice is that at 3, I cannot accept 3 as a solution because 3 is not less than 3, it is equal. So since I do not have this equality sign here, if I do not have the equality sign, then this has to be an open circle. If there was x less than or equal to 3, then I will make this a closed point. That means that point is included as well. But in this case, for this example, 3 is not included, so we will show it with an open circle. So let me draw it this way. So this would be, if you want to draw the solution, all the numbers less than 3, this blue line. Maybe sometimes they draw this and say this is the shaded area all these numbers are acceptable. 2 is possible, 1 is possible, 0.5 is possible, -1 is possible. You can try it. Let's say if you pick some number less than 3, something like 0, for example. Does it work if I replace the inequality? 2 times 0 is 0, minus 1 is -1. Is -1 less than 5? Yes, it is. So therefore, that's correct. And so on. If you pick any number less than 3, you will see that this is a true statement. So this is if they ask you to graph your solution. This is how the solution set looks like. Sometimes they ask you to write the interval form of it. How do you write it as an interval? So here, from -infinity to 3. 3 is not acceptable, so you use parentheses. That means 3 is not acceptable. So I'll say the solution is from -infinity to 3, open parentheses. If 3 was a closed circle, then I would use bracket and say this is the interval. There's a difference between these two solutions. This one is x less than 3. This one is x less than or equal to 3. If you have the option to have equality, you should have a bracket. Infinities are always parentheses because you will never reach infinity. So this is always parentheses for infinity. But for the constant 3 in here, this is your solution. Since it's less than, you do not have the equality. But if you had the equality, this would be the solution. So here, let me erase this. For our case, this is the solution. Let's try another example. Here, we have equal sign. So what do? Again, you try to isolate x, subtract 1. It's like you're solving in a linear equation. You get -3x greater than or equal 4. Be careful. Now, at this point, I can divide both sides by -3. What do I get is divide by -3, divide by -3. Left side becomes x, right side becomes -4/3. But since you divide by a negative number, you have to flip the sign. X less than or equal to -4/3. This is your solution set. The solution set is all those x's such that x is less than or equal to -4/3. Okay, can I draw the interval? Can I draw a graph of it? Yes, this is, let's say, -4/3 is somewhere on the number line. This is -4/3. All the x's less than -4/3 means here is -4/3. Everything less than that. Is -4/3 a part of the solution? Yes, it is, because I have an equality sign here. So I should make that a closed circle. That's the only difference between the open circle and closed circle. So now, this is the graphing. How about the interval notation? Interval notation is from -infinity to -4/3. And -4/3 is included, so I'll use a bracket. This bracket is important to show that this is possible to replace -4/3 as a solution. Okay, let's try the next example. Here. Okay, if you remember when we solved a rational equation, we didn't want to deal with fraction. The same idea holds here. I don't want to deal with fraction. So what do? Is I will multiply everything by a 6. 6 times, it's a common denominator, so I can get rid of all the denominators. 6 times x plus 3 divided by 2 minus 1/3. On the other side, I have greater than or equal to 6 times 1. Let's distribute 6 times this one, 6 times the other. It would be 6 times x plus 3. I'm going to write it step by step so you can see what am I doing. Minus 6 times 1 divided by 3. I'm distributing to each fraction separately. Greater than 6 times 1 is 6. Okay. Left side, I can simplify 6 and 2. This becomes 3. And here I can simplify 6 and 3. And this is 2 times 1. So finally, let me continue here. I'll have 3 times x plus 3 minus 2 times 1 is 2, greater than 6. And since we multiply the positive number, I didn't need to flip the signs, if you remember. At this point, it's a linear equation. Add 2 to both sides. you get 3 times x plus 3 greater than 8. Divide both sides by 3. These two will cancel out. I have x plus 3 is greater than 8 third. Subtract a 3 from both sides. X is greater than 8 third minus 3. And if you simplify that, is 3 is 9 over 3. This is the same as 9 over 3. So 8 third minus 9 third is negative 1 third. Do not flip the sign because you didn't multiply or divide by a negative number. This is just the result. X is greater than or equal to negative 1 third. What is the solution set? Solution set all those x's such that x is greater than negative 1 third. And how does it look like if you graph it? You don't need to be precise. Let's say we call this negative 1 third. What is the solution? All the x's greater than negative 1 third. This is negative 1 third. It's not possible to have a closed point because you do not have the equality. All the x is greater than that. So this is your solution. So it means any number here is a solution. 0 is possible, 1 is possible, and so on. Something like square root of 2 is possible. Okay, how do you write it as an interval? Interval becomes from negative 1 third, open parentheses, to positive infinity. Okay, this is positive infinity. You always write interval from left to right, smaller to larger. So do not forget that. These are very simple cases of solving linear inequalities. We have something called compound inequality. That means it's a combination of two inequalities at the same time. If you have two inequalities, x less than a and x greater than b, sometimes they write it this way, x greater than b as well as x less than a, two inequalities. This means find each inequality. So and means you want to satisfy both inequalities. So if that's the case, this means take the intersection. Intersection of what? Intersection of your solution set to x less than a and x greater than b. Find each one separately and take their intersection. You want to satisfy both inequality. How about or? If x less than a or x greater than b, this means find the union. You want to satisfy one at least, either x being less than a or x being greater than b. Okay, the and or is the logical term for intersection. This is the intersection, if you remember this format, and or is the union. So you have two sets, you want to find the intersection or the union of those two sets. I'll do example of each one so you'll see. So here, solve these inequalities. 1/4 y less than negative 1. So I'm going to solve each one separately. Okay, 1/4 y less than negative 1. And on the other side, I have 3 plus y greater than 5. Okay, left side, you can multiply both by 4. You'll get 4 times 4. Since you multiply a positive number, you don't really need to simplify. You don't need to change the sign. So y is less than negative 1 times 4 is negative 4. How about the other equation? You can subtract 2 from both sides. Y is greater than or equal to 2. Okay, graph each solution. This is your solution set, by the way. These are the two solution sets. If you graph them, it's better to graph them separately, so you'll see first, then here. Negative 4, 2. Y greater than or equal to 2 means 2 is acceptable, everything greater than 2. Y less than negative 4 is negative 4. It's not a closed circle, it's an open circle since you do not have the inequality, everything less than that. These are your solution. But what you want is you want to have them together because of the or means you want to satisfy either this one or the other one. So this is a union form. So what do? Is I'll write the solution set and say, okay, the solution set is all those x's such that it's a y, not x's variable. All those y's such that y is less than -4 or y is greater than or equal to 2. This is my solution set if you want to show it as a set. If I want to graph it, I'll graph those two together and say, here's 2, here's -4. You put the numbers on number line in order. -4 is smaller than 2, so that's where I put this number. Okay, graph the first solution was less than 4. The other solution was 2 and everything. If they want it as an interval solution, what is your interval solution? This from -infinity to -4. -4 is open parentheses. Union from 2 to positive infinity. But 2 should be a bracket because it's a closed point. 2 to positive infinity. This is how you show your solution. If you have a case when it's or, you use the union. That means you want both solutions together. If it's an AND case, something like this. This example, sometimes they write it as, this is one way to write it. Sometimes they write it as -16 is less than -3y minus 4. And you want -3y minus 4 less than 2. These two are equivalent to each other. Writing it this way or this way, these two are exactly the same representation. Okay, so how do you solve them? Similar to the OR case. Solve each one separately. I'm going to solve each one separately. Here, left-hand side is -16 less than -3y minus 4. Let's solve that. Then solve -3y minus 4 less than or equal to 2. I will solve this one as well. Just add 4 to both sides, divide by -3. So add 4 becomes -12 less than -3y. Divide both sides by -3. Left side becomes 4. Be careful. If you divide by a negative number, you should flip the sign and you have y. So 4 is greater than y. And how about the other part? You'll have -3y minus 4. Similar idea. Add 4, You'll get -3y is less than or equal to 6. Divide both sides by -3. By dividing, you have to flip the sign. Greater than or equal to -2. Dividing by -3. Okay. So what is my solution set? Solution set. I can write them both all together. All those y's such that y is greater than or equal to -2 and y is greater than 4. There is a shorter solution for this, but I want you to see that you can combine these later. By after you graph it, it's easier to see it. This is my solution set. You can write it shorter because they have something in common. You want to satisfy both, so you have to find out where is that common area. Let's graph it. Here. Where is y less? This, by the way, this 4 greater than y means this has the same meaning as y less than 4. These two are the same. If you write the y on the other side, it means y less than 4. So here I will find 4. Y less than 4 means this is the solution. Y greater than -2. Here's -2. -2 is included. Y greater than that. This is the area that you're looking for. Okay, if you graph them together, I'm going to draw here so I can write the solution set later, shorter for you to see. Find those numbers in order. Here's -2, here's 4. Okay, what is the part that they have in common? I'm going to draw them so you can see. Here's the -2 part, -2 and everything above it. This is the area. That's the first solution. This is this one. First solution. Sorry, second solution. This is the red one. I'm going to use maybe a different color for the green here. For the other one, number 2, I'm going to use green. 4 and everything smaller. 4 is open circle. Everything smaller than 4. Now it is clear when you draw it this way that what is the common part? I'm going to use a third color. I'm going to use yellow. The common part is specifically this area. Maybe I should do this. This is the area that they have in common. So how do I show this area? You can show it by saying there is a open circle at the end and closed circle at -2. Open circle at 4 and closed circle at -2. I wish I would have used a different color, so just maybe use black here. Open circle here. Closed circle on the other end, because -2 was closed, 4 was an open circle. And how can I show this in shorter as a solution set? And write it as y such that, where is y? Y is between -2 and 4. Y between -2, and since it's included in -2, use equality for it, and less than 4. 4 is open circle, so it's strictly less than 4. This is a shorter way of writing the solution set. You can write it as interval. What is the interval? Interval is -2 closed, 4 open. This is your interval notation. Interval notation of the solution. I hope it's clear. And I'm going to stop here, and next time we're going to discuss how to solve absolute value inequalities.